Okay, let's start our session today. Welcome everyone. It's a great audience. Good to see everyone here for our session on understanding the value of dependency injection on the Lightning platform. So, dependency injection, forewarning, is a complex topic. 20 minutes is by far not enough to do it justice. So, the value of this is what we're aiming to get out of it for you guys. So you go away with understanding of what it can do for you, the benefits of it. We have a host of resources and blogs and videos that have been compiled over the last several months from John and Doug and myself for you to dive into after this session. So our main goal here is for you to get a sense of what it is fundamentally and the value it can bring to you, and then go away with some ways to learn more about it. So with that, we'll get underway. This is a session about dependency injection and patterns, and both myself and Doug are Salesforce employees, but essentially this is a session about industry patterns, and we'll be talking about an open source library. So obviously this isn't a Salesforce product. It is a session just to give you guys a flavor of what this pattern means and how it could be adapted to Salesforce, but our standard forward-looking statement still applies to make your purchase decisions on what's available today. So our general agenda is to talk about why should we be thinking about dependencies in the first place. You know, perhaps the first thing you might be asking, rather than thinking about what dependency injection is, was what is a dependency and why is it something I should be concerned about and give more thought to. So we'll understand what the different types of dependencies are on the platform. Some of the most immediate ones you think about are, of course, the dependencies you form at a code level, but there's quite a few other dependencies you can form elsewhere on this platform. So we'll look at the overview of what the pattern is. We'll look at some implementation techniques that we've used with various Apex and Lightning programming techniques and APIs. Doug's going to take us through a use case and a demo. It will solidify some of that, those learnings and principles, and hopefully give you that sense of the value of what can be achieved with it. And finally, I'll wrap the session up with a bit of talk about test-driven development. So as a quick show of hands before we get underway, how many people are familiar with dependency injection, either on this platform or others? Fantastic. Right. I think we've got an easy job here, Doug. Yeah. No, just kidding. So also test-driven development. How many people are also familiar with test-driven development? Great show of hands. Fantastic. OK, let's get cracking. So we've got a conversation playing out here. Astro's thinking about how they can develop better unit tests. Obviously, we understand, I think, by the show of hands here, a unit test is more focused on the particular element of code that you're writing rather than the overall process that's being constructed. So how can Astro think about writing unit tests that don't have the expense of all of the setup code that's required for all the different code paths? Obviously, all the code that we write is very precious and dear to our hearts. We want it to live long and continue to be beneficial. So how do we manage that cost of change? Requirements, business, our requirements change all the time. How do we protect our code from that change as much as possible? Ultimately, we want to figure out how we can deploy not the monolith of our code, but our code in separate modules, so it makes it more easier and versatile to deploy. Now, Cody's understanding and listening to this conversation is making some observations about the questions being asked here. And the key observations really derive down to how we think about all of these things in a common way. And the common element throughout all of these is how we think about the dependencies and how we manage all of these things. All of these questions that are being asked fundamentally come down to dependency management, how you couple your code or manage that linking between your code. Dependency injection is a design pattern. It's not unique to Salesforce. You can look it up. It's available in other platforms and other languages. There's many other blogs, some of which we've linked to on the open source repo for your reading, that have been written about it. Essentially, you can think of design pattern as something that helps you loosely couple your connections so they can be interchanged like Lego pieces. You can plug and play different implementations. We'll see that in the demo. That gives you that kind of future-proofing of your code. Something that maybe is going to change in the future requires some kind of thinking of coupling so that you can not disrupt other parts of your code while that thing changes in the future. So requirement change is a part of life on development on any platform, and being ready for requirement change is a key part of understanding dependency injection. When we look at some of the ways in which you can form dependencies, then clearly class A referencing class B is a dependency on those two classes between each other. We also form dependencies when we create declarative experiences, when we create a layout and we have some fields on there, or maybe you have a Lightning component on a page. or Lightning components invoked by an action, those are dependencies between that declarative action and that Lightning component. We also have triggers. We might have trigger logic, which is dependent on a particular object. And how do we think about the dependencies between that logic and the object? So there's many dependencies on the platform, and the red lines on this diagram represent how we might think about those. Now, this isn't to suggest we should go to town and think about dependency injection at every single point where these are made. You need to think about the strategic places where those dependencies are formed and whether it's worth having that flexibility. So when we look at a dependency from the purpose of Apex, and we look at that from the point of view of Lightning, we can see that dependencies are formed syntactically in different ways. With the new operator in Apex, when we're constructing A, whatever code that's constructing A makes a dependency on that. It's explicit reference to the class A. Similarly, when we're using a component called A, we use that XML markup tag. That's referencing that component explicitly. The metadata example is somewhat generic here, but ultimately you might look at the object schema, the object metadata file, and you see your actions in there. They specifically reference maybe Lightning components. That's a metadata dependency reference as well. So those are what we would call explicit design time dependencies. You're probably most familiar with those. The trouble with those is you need to change your code to change those dependencies, and each time you need to go through and look at all of the places those dependencies are made and figure out where you need to make those changes. It's not quite as agile as you might like if that requirement is changing all the time. So let's think about how dependency injection works, and immediately you'll observe this diagram looks a lot more complex. Well, that complexity comes with greater flexibility, of course. So rather than using the new operator in Apex, we're using something called an injector. And the injector's role is to relinquish the client code, in this case the code that instantiates A, from the knowledge of how to obtain an instance of A. That's not its concern. It just needs something that performs the role of A. It has certain methods on it, certain behavior. So the injector knows where to go to find out an implementation of A. And that might be dependent on the sandbox, it might be dependent on production, the test environment. You can plug and play different implementations of A to suit your requirements. All the while, the client code is completely unaware of the different implementations. Lightning is much the same. We've got an injector. So you're seeing a first glimpse here of our open source library, Force DI in practice. That's the DI underscore denoting the classes and components that come with that library. When we think about how to actually achieve dependency injection. In Apex, we simply use the alternative to the new operator and go through the injector and give it the name of a binding. That's the name of the thing that we're expecting. In this case, we're using A class as the name of the thing that we want to look for. And we've got a few options. You don't always have to use interfaces if you're not familiar with interfaces or base classes, or you just find those too much of an overhead. It's not actually a requirement to use interfaces and base classes to achieve this. We do have the option of just simply instantiating another version of A straight away, or we can use the actual test implementation, so the mocking framework, the test.create stub to create an instance of A, or we can have A be a base class or an implementation. So you really just need to think about the thing that defines the contract of the dependency. What are the methods that are going to be expected and the behavior? Whether it's a base class, a concrete implementation of A, or an interface. It's got to be one of those things that allows you to plug and play different implementations of A. So these are the different options for expressing the thing that you're binding to from a dependency injection point of view. You're basically aiming to make sure that the client is unaware of actually how A is implemented. So with that, Doug's going to start walking us through a use case so you get a better understanding of how some of this technology I've just blown your minds with in terms of how it works with our library goes. And Doug, take us away with that.
Awesome. Thanks, Andy. So let's talk about Widget Company. Salesforce customer. They love extending the platform with the Salesforce platform and Salesforce DX. They have been developing several different apps, one around support for their customer service teams, managing cases. They got another team developing a finance application, going over their sales process and opportunities. And now they're in development of a shipping application to work with shipping logistics providers on how they're sending out their products. Now, they have a current contract with one logistics provider, but they know in the future they might want to swap that out. And so they're looking for ways to architect their application so that they can swap out that implementation, different providers, without having to do a major refactoring of their application. So let's jump into the demo and see how that's going. All right. So here we are in our shipping application. I'm going to go ahead and create a new record. And I'm going to leave the cost fields blank for now. All right. Now, to the end user's perspective, this looks like some simple field updates to assign the cost. We probably have a Lightning component here in the upper right for our tracking number and a support form flow. Probably assembled together in the Lightning app builder through drag and drop. But what's actually happened here is much more complicated. We have Apex classes and triggers developed, and then we have Lightning components and visual flows all being developed by separate teams in separate Scratch orgs and being released through separate unlocked packages, but they all come together on this one page in real time, driven by custom metadata configuration. So let's take a look at how we can swap out, perhaps, from the Express ship provider to another logistics vendor by just editing a couple metadata records. So here in Setup, I'm looking at my bindings custom metadata, and I'm going to edit the class that calculates that shipping cost. So instead of injecting this Express ship provider, I'm going to swap it out to another implementation, Happy Ship Co-integration. Same thing with that Lightning component. I have a binding here, and we'll jump into the code here shortly. But instead of referencing the Express ship Lightning component, instead I want to refer to the Happy Ship Co Lightning component. Now we go back to the application, and I'll create a new record. Again, I'll leave the cost blank for now. And this time around, we have a different cost calculated, 150 instead of 100. And we see that the Lightning component has been swapped out too. So how did we go from custom metadata to driving and influencing the functionality and behavior of application? Well, let's start by looking at the Lightning record page for shipments. Indeed, we do have two components on the page, one called shipment tracking and one called shipment support. So let's take a look at the code behind those. Here is the code behind the shipment support Lightning component. And you'll quickly notice there are no references to flows. Instead, we have from the ForceDI framework the injector component, and it's looking for a binding called shipment support. If I jump back to my custom metadata bindings, scroll down, we'll see that I have a shipment support binding here that refers to a flow. And that's the flow that we saw on the page. Well, let's go back and think about the tracking number. It too has no reference about the Express ship or Happy ship or any other provider implementation. It has the one tag, the injector tag, looking for a binding called shipment tracking. Go back to our metadata records, and for shipment tracking, it refers to a Lightning component. And this Lightning component name that we provide here is dynamically being created and put on the page in real time. Now, the cost is being calculated through a trigger. And our application follows the best practice of one trigger per object. And just like the Lightning components, you don't see any references to the specific providers or implementations here. We have the one line for the trigger injector to go find all the Apex handler classes that are bound for this S object. So we go back to the metadata records, and we'll see here that we have two that are bound to the shipment S object, a cost trigger handler and a cost center trigger handler. So let's take a look at what that code is doing. In the trigger handler, it extends the trigger injector trigger handler class. But really, like any other trigger handlers you've probably written, it grabs a reference to the new records and then delegates that off to our actual classes that have the business logic in it, right? In this case, we're calling out to a class called shipping provider. Let's see what that method's doing. Here, the calculate cost of that shipping provider class is actually deferring out to a shipping integration interface. But we haven't tightly coupled, we haven't explicitly said what class is providing the logic behind calculating that cost. Again, we're using dependency injection to look up in real time what Apex class we want to call. In this case, a binding called shipping integration. We go back to the metadata records, and that was one of the first things I edited, is we went from the Express ship to the Happy ship. Well, what is that class doing? Here, it's simply implementing the shipping integration interface. This interface was bundled and released through the base apps unlocked package. This implementation was provided through a different unlocked package. And through the custom metadata, we're able to plug and play, swap out in real time which implementation we wanted to use. Now, so far, we've looked at declarative configurations for the dependency injection. But sometimes you need to be a little more expressive on what bindings you're going to have. And you can do that through Apex, through something we call a module. So let's take a look at the shipping log module class. In this instance, we extend from the DI module, and we have one method called configure. At this point, you can be running SOQL queries, HTTP callouts, inspecting based on the current user, and define one or more bindings to different implementation classes. In this specific example, we're interrogating the shipping log webhook, kind of asking it, does it think it's configured? And behind the scenes, that's making a SOQL query looking for specific name credentials for the endpoints to use. But if that's not there, then instead of wiring up to the webhook class, instead we wire up a different binding to log information to a custom object in the database. So this is just a simple example of how you can provide conditional logic. And this also runs in real time, so you really have that dynamic sense with your bindings. And with that, I'll pass it back to you, Andy. Oh, there we go.
Okay, thank you. Excellent. So yeah, Doug talked us through an implementation of DI across Lightning components, how we can inject flow and Apex code into each of those situations. Let's think about an element of that in a bit more detail. That shipping provider class provided some useful functionality in terms of how to log and how to calculate cost. That's a fundamental requirement regardless of which shipping provider you're using. If you're following test-driven development, that class has some functionality that you want to test. You don't want to have to wait to have the integrations developed and decided upon. As a developer, you've been asked to create a shipping provider class that's got two methods on it, interacts with the integration classes and the logging classes. And you want to go ahead and start writing some tests around that. And that's really powerful because it keeps things moving. It keeps your code development moving and your test development moving all together in parallel. You're not delayed waiting for more code to be written that you need to be dependent on. So dependency injection has allowed us to get started writing some tests from the outset. So as Doug mentioned, the shipping provider has two interfaces. The one that expresses the logging requirements whenever you want to log a shipment. Another one that actually expresses the type of integration, how you might calculate the costs for that shipment. And in reality, the green boxes below show that we have multiple implementations. But we've not written those. Imagine right now we're sat at our keyboard, we're just writing that shipping provider class. Nobody's written those implementations, or even at a business level, perhaps even decided which of the two providers to go with. So that's completely absent information. But we've got some concrete requirements to start with. So let's see what that looks like in terms of the code. So Doug highlighted very briefly the shipping provider. It's using the injector. So it's not explicitly having to instantiate the shipco or the happy shipco classes here. That would be hard coding those assumptions. Plus, you'd have to write those classes in order to instantiate them. What we're doing is saying we have a dependency. We expect these interfaces at some point to be fulfilled. And then we're going to call methods on them. So when you call the calculate cost method, it'll call the calculate cost method on that. Isn't terribly sophisticated for the purposes of this demo. The ship method does go through a little bit more logic that you'd want to test. What happens if the ship method fails on the integration class? Then it calls a log and it passes a certain status in of failed. Otherwise, you get success. So we've got some behavior to test here, even though we don't have the implementations. So how do we do that? How do we magic implementations out of thin air in order to actually make this code execute? So that's mocking. We need to mock these implementations. So we're using, in this case, the default test.create stub method. I can see a few Financial Force fellow colleagues in the audience, so it'd be incumbent on me not to reference the lovely Apex mocks as a more fully baked out implementation of mocking. But we're showing this in a very basic way, where we're creating the stub. And the create stub method will basically emulate an implementation of that interface for us and give us some callbacks that pretend to be an implementation of that. So we're providing those bindings, much as Doug showed, to allow us to dynamically bind to those implementations. In our actual test code, when we run the test, we then assert that we've got the values back. Now, the stub method allows us to implement the stub provider. So this is where we're doing that emulation. We're pretending that we have implemented the interface, and when we get asked to calculate cost, we'll just give 100 back. When we're calling some of the shift methods, we'll emulate an error scenario. So you're able to sort of emulate all the conditions that drive the logic that you've written in your code, and really tightly test that code in all possible conditions before anybody's even written a shipping integration, which gives you a great deal of confidence. So basically, we'll wrap it up there. It's been a bit of a whistle-stop tour. Hopefully, we've done a great job at giving you a great deal of understanding of the value and the benefits of it. We'll certainly be able to take some Q&A. I see we've got I think we're over time. Is that correct? I'm looking at anybody in the audience. Yeah, we're definitely over time, so apologies for that, but thank you very much.